The traditional type of dribble bar would actually hover above the ground. This one operates on these springs, so it actually sits directly on the ground with a little bit of pressure, and this blade makes a tiny trench in the ground where the liquid manure pours out this opening, capturing more of your nitrogen.
I am Judith Nyiraneza. I am a soil scientist working for Agriculture and Agri-Food Canada in Charlottetown. This BMP6 refining nitrogen management from liquid manure application is part of Living Lab PEI, and Living Lab is all about a collaboration between scientists and end users to identify different farming practices to mitigate climate change.
I'm Steve Reeves, the sixth-generation dairy farmer. We operate Reeves Farms here in Prince Edward Island, my wife Jessica and my parents Kate and Farrell. This project really got started during a Living Lab co-creation meeting in the winter, and Kyra Stiles from the PEI Department of Agriculture contacted me and talked about doing a project on liquid manure, and it kind of went from there.
Kyra Stiles initiated the project, and myself and Jeff Campbell, the dairy and livestock specialist for the province. We are kind of the connection between the producer and the scientist and our researcher, and we just help facilitate the project along. So this trial is comprised of 3 components. We're doing a check strip as a baseline, and then the next component of it is the splash bait, and that is what the producer typically does. And then the final component is what the producer is trying new, which is the dribble bar component.
Nobody was selling them in the province, so I had to source it outside Prince Edward Island, then arrange shipment from Europe, which took about a year to get it here.
The common practice is to broadcast manure, spreading liquid manure in the air, which is not good for neighbors because we have high odors. So instead of having your liquid manure spread in the air, the dribble bar is going to apply really right on the ground, and you can have all your manure where you want it to be.
The odor is way less, which shows us that we're capturing that ammonia in the soil, and it's there to benefit the crop that's growing.
We're measuring yield, and we're also measuring GHG emissions on that, as well as we're doing soil sampling.
Greenhouse gas is one thing we are looking at. We use what we call static chambers, targeting 3 gases: methane, carbon dioxide, and we have nitrous oxide emissions.
Traditionally, we would just spread all the liquid manure in the spring, and then again late in the fall, so we'd have enough room to get through the winter. Fall application, we weren't getting much benefit out of the nitrogen in the manure because it would leach away over the winter. So with this technology now, we are spreading in the spring, and then after each cut of forage, we are spreading again. So in the fall, when we traditionally would be late fall, we'd be emptying our pits. Now they're empty, and we've gotten the value of those nutrients all summer while the plants are still growing.
Refining nitrogen management is an important strategy to mitigate climate change. So we want to make sure we apply the right product at the right amount, at the right timing, at the right place.
We as farmers are on the front line of climate change, so we're trying to work toward net zero hard. The dairy industry has actually promised to be net zero by 2050. And these are the type of technologies that are going to get us there. We feed the plant to the cow. She produces waste as a byproduct of the producing milk. That waste can then be reapplied to the fields. We're capturing most of the nutrients from that waste, regrowing the plant to feed the cow again. So I think that's how, another 6 generations on the farm is going to happen.
The result be important to the growers to make informed decision, knowing the benefits of applying manure using different methods. I see more growers adopting the dribble bars once they will see the benefits associated with it.
I think farmer-led research is very important to see real-world results. In the laboratory it works, but when you try it in the real world where things go wrong and weather conditions are different, it's really important to have that on-the-ground, real farm experience.